All right, guys, so we're looking at volumes of solids. So we just finished doing a couple of weeks of surface area, and now we're looking at the same exact solids as we did before, except for we're looking at the volume. So what's the difference between surface area and volume? Surface area is akin to, like if I give you a shape, it would be like painting the outside, right? So what would volume be?
Like filling it with paint.
Filling it with paint or filling it with water, right? But I mean, it's the idea of filling it rather than just covering it with paint, right? All right. So we've got a few more formulas to learn. Prism and cylinder have the same exact formula in the sense that you're going to take the base shape, whatever that base shape is, and you're going to multiply it by the height, where the height represents the distance between those two shapes. Okay. Notice that if I rotated the shape on its side, the height won't look like the height, but it still is that distance between the two shapes. Does that make sense? So the height might be on its side. Watch out for that. But you're looking for what is my base shape and what is the distance filling in between them. Same thing with the cylinder. It's just that your base shape is always going to be a circle, no matter what. So here, the only thing I could really do to make this problem difficult is to give you a more difficult base shape, right? So if I give you a square base, this should be very easy. If I give you a hexagon base, now it's getting a little bit trickier. But it still should be completely doable because how long have we been finding areas of hexagons and pentagons and everything like that? A long time, right? So that should be by now something that you're comfortable with. So when I say find the volume of a hexagonal prism, finding the area of the hexagon should be a piece of cake, and then all you're doing is multiplying it by one number that is the distance between, right? So ultimately, this problem computationally shouldn't be any more difficult than what you guys have done in the past. You just have to remember that the volume of a prism and a cylinder is base shape times the height, and that's it. Got it? Okay. So most difficult task is to make sure that you correctly identify the base shape. So for this first one, is this rectangle your base? Right. So that's where you have to be careful. I might not put the base on the bottom, right? Remember that a prism's base has to have that shape repeated directly above it, right? So when you're looking at that rectangle, do you have another rectangle up here? That's why that's not the base. Right? Whereas if you look at the triangles, do you have another triangle directly opposite of it? Yeah, you do, right? And so in that sense, that's why those are your base shapes. So what we're going to do is we are going to find the area of one of these bases, and then all we're going to do is multiply by that distance between the two bases. Notice that this is one of the situations where the height of the prism is actually laying on its side. But this technically is h because it's the distance between the two bases. Does everyone understand that? Okay. So when I'm doing the volume, I know that I am doing base times height, where my base is that triangular shape. And what's my height?
3.
Yeah, 3. Technically the distance between the two bases. How do I find the area of that triangle? 1/2 base times height. Good. So you're going to do 1/2 times the base of the triangle is... Yeah? Uh-huh. It was just me drawing a little triangle. Yeah, just saying that it's a triangular shape times 3. And now I'm finding the area of that triangle. So it's going to be 1/2 times the base of the triangle, which is 2, good, times the height of the triangle is 6, and then that times that 3, the distance between the two bases, right? So the 2's cancel, and then you just have 6 times 3 is 18, and you're done. Okay, let's look at the other shape. What's your base shape for the cylinder? It's a circle, right? So what you're going to do is find the area of the circle, and then you're going to multiply that by the height or the distance between the two circles. Okay?
Do you want us to do?
So, what?
Do you want us to use the pilot?
No, let's leave it in terms of pi actually, so that it's perfect. So we're doing volume equals, it still is base times height, so same exact formula as the other one. The difference on this one is that my base shape is now a circle rather than a triangle. So I'll be finding the volume or area of that circle times the distance between the two circles is 13. Good. How do I find the area of a circle? Pi r squared, so that will be pi times 4 squared, which will be 16, yep, times 13. So like I said, let's just leave this in terms of pi since that'll be easier. What is 16 times 13? What is it? 208. So you have 208 pi, and then we can quit there. Any questions on either of these shapes? No? All right. So then, as usual, I can work backwards. What if instead of asking you for the volume, I say, here is the volume, and I ask for a missing dimension? Do you change what formula you're working with? No. All you're changing is what are you filling in about that formula, right? So for the first one, is that a prism or is that a cylinder? Prism. Technically, you can make any of those things the base, but what would be the easiest base to make? To me. I think the easiest base to make would be the squared, personally. So that you have the base shape's area is just going to be x times x, right? So what I'm going to do is call this the base. Technically, you could call, the top rectangle and the bottom rectangle the base, but for some reason I just like this better. But you can try it the other way and it should still give you the same answer. What will be the height then if I make this my base? Good. The distance between the two squares is going to be your 11, right? So I'm still using the volume equals base times height. The difference is that now I get to fill in V right off the bat rather than trying to find it. So what is V? 396. What is the area of the base that I've highlighted? X squared. X times x for that square, right? So the area of this base is going to be x times x, x squared, and then times the height is 11. So to solve this, I'll divide 396 by 11. You guys should get 36 when you do that. And then to solve for x, you will square root both sides. So I will get x equals 6. And then that's all that I was asking for, was that dimension for x. Any questions on how we worked backwards for that one? Yeah.
Wait, why did you put x squared?
Because I called this my base. And the area, so the formula is base times height, right? So the area of that base is length times width, which is x times x. And x times x is x squared.
So the volume, can you just do base times height?
Yeah. Yeah. But only for a square based or a rectangular based. Yep. Yeah, so she just asked, can't you just do length times width times height? And that is true for any cube, right? You can do that. But if I were to give you a triangular base or a pentagonal base, that's not going to work. So that's why I'm kind of sticking to just using this formula over and over and over again. But yeah, if you know that length times width times height for a square or rectangular base prism, that's fine. That's okay. All right. So for my right cylinder, for part B, I know that I have circular bases. I'm told that the volume is 277. The diameter is x, but I'm not really going to work with the diameter, am I? When I find the area of a circle, what do I usually use?
Radius.
The radius, right? So I'm going to just write r for radius, and then I'm going to remember at the end that x is going to equal 2 radiuses for the diameter, right? but I just need to find that radius right now. I also know that the height is 5. How do I set this problem up? Yeah. So Kyla is saying 277 equals, and she's about to go into that formula, but let's also kind of start at the same spot. So we're plugging into volume equals base times height. The volume is 277 equals, the base shape is what? A circle, and what is the area of that circle? Yeah, because you don't know the radius yet, so you can't plug in for it. All you can do is say pi r squared. Okay, and then that's times the height, which is 5. All right, so how do you guys want to solve this? We need to solve for r, right? That's actually the hardest part of this problem, is getting r by itself. What do you want to do? Divide by 5 pi, she said. Notice that she did both the 5 and the pi, because eventually we're going to have to get rid of both of those to get r squared left alone, right? So if I divide by 5 pi, that cancels the 5's, and it also cancels the pi's, right? But I have to do that on this side too. Now, what do you have to be careful about at this step? You have to put parentheses around the 5 pi if you're going to put this in your calculator. And this is probably one that I would have you round, because 277 doesn't divide evenly by 5. And rather than having you leave it as an ugly number like that, I would probably just say go ahead and round this as a decimal. Okay? So when you do 277 divided by 5 pi in parentheses, and I don't have my calculator out, so I'm going to trust you guys to give me the right answer here. Round it to the nearest tenth. What is 277 divided by 5 pi? It should. I don't think you put parentheses around your 5 pi.
If you don't put the parentheses around, you get 174.
Okay, that's also not good. Oh, we haven't square rooted. That's why. I'm sorry. I kind of have an answer in my head that I know is coming up. So 17 point what? 6343. Okay, sorry, I was one step ahead of the game there. So then to find r, we need to square root both sides of that, and that's the answer that I kind of have on mind. When you square root that with those 4 digits after the decimal, what do you get? So type in square root of 17.6343. What do we get? $4.999? Okay, that's what I was looking for. So rounded to the nearest tenth is 4.2, right? So that means if my radius is 4.2, what is my x value? 8.4, doubling it, right? Because my x value is supposed to be the diameter. So I would double my radius. And then this is your final answer. Are there any questions on that problem? Okay, so that's it for prisms and cylinders. The only thing I can do to make that more difficult is what? Different number of sides on the base, right? So if I were to give you a hexagon or a pentagon or something like that, I can make it more difficult in that sense, right? All right. What are the next 2 shapes that you're expecting to see? Cones and pyramids. Yep, good. And yes, these are a little bit more difficult than the last ones, because remember, with the pyramid, you get a bunch of different triangles that can happen in there, right? I have a regular height, I have a slant height, and I have a lateral side along with the base shape. So there's just a lot going on in that. Okay? Notice with your volume formulas, what's the only difference between a prism's volume and a pyramid's volume? It's 1/3. Yep. It's 1/3 of the base times the height. And that makes sense because when you take a base shape and you taper it up to a point, you lose volume on that. And it just happens that if you have a perfectly regular base, and notice that that's the note I've made down here, that this formula, it only works if you have a regular base, but I'm only going to give you regular bases, so you don't really have to worry about that. Okay? So with regular bases, you can just take 1/3 of the base times the height. And that's the same thing for the cone. It looks similar to a cylinder, but you lose a third of the or you lose 2/3 of the volume when you taper it up to a point. Okay? All right, so we're going to start with pyramids. Now, in surface area, did I ever give you a pyramid where it was slanted like that? No. And that's because that gets way more difficult for surface area. Because notice that, remember for surface area of a pyramid, you were trying to find the area of one of the triangular faces, and then you just multiplied that by 6, right? But now when I slant it, do your faces stay the same area? So that's why this gets more difficult for surface area, and I wouldn't give that problem to you for surface area unless it was like a bonus or something, okay? But for volume, it does not change the difficulty here. Now remember that when I first taught height in pyramids, I said that the regular height, so you have the slant height that goes down the face, right? And I kind of told you could think about the height h as being if you stood at the top of the figure and you dropped, oops, sorry, 1 second. Okay, sorry about that. So like I was saying, I taught you guys to think of the height h as being if you were to stand at the top of the figure and drop a rock, what path would that rock follow? That's your regular height. So even though this 5 isn't dropping down into the center of the pyramid, is it still that same perpendicular height that would fall straight down? So that is still your regular height. Okay? So when you're finding the volume for a prism or a pyramid that has a regular base, what formula are you using? Volume equals what? 1/3 of the base times the height. So that's the very first thing you should be putting on your paper. I am only teaching you these two formulas today. Base times height for prisms and pyramids, or I'm sorry, prisms and cylinders, and 1/3 base times height for pyramids and cones. So if it tapers, take 1/3 of it, right? So when I'm talking about volume, you're either putting base times height or 1/3 base times height immediately. Pick the right one is the first step, right? Once you've got that down on your paper, you should have a pretty good direction to go with. Because now I'm looking at this and I'm like, okay, I need to do 1/3 of, the base is what shape? A what? Hexagon. And do I know how to find the area of a hexagon pretty well? Right. So remember, for the area of a hexagon, you're looking at this little triangle right here, right? I'm going to draw it off to the side so I can kind of mark it up a little bit. So when I look at that little triangle, what is this top angle and why? So a lot of you guys have memorized that it's what? 30 degrees. And if you didn't remember that it was 30 degrees, how would you calculate that? Right, divide 360 by double the number of sides, 12. That would give you your 30 degrees, right? So I now know that this is a 30, 60, 90. And I know I'm going to use special ratios. Which side length do I already know on this thing? The base is 1, since it's half of the original side, right? Okay, now however you guys need to go about doing this, you need to find the height of this thing in order to find the area, right? So some of you guys might use that home base method I taught. Some of you guys might use fractions. Some of you might do something a tutor taught you. It doesn't matter as long as you get there correctly. Right now I'm going to do the fraction method so that I don't lose anyone. If you like the home base, then do the home base on your own right now, but try and find that height. So I would be doing x over, and what would I do x over if this was a fraction method? What ratio matches the x? The square root of 3 equals, and then I would do the 1 over, and what ratio matches the 1? 1, right? And then how would I solve this? I would try and get x by itself by multiplying this root 3 over to this side. So then x would just equal the square root of 3, because 1 over 1 is just 1 and we can drop it. Okay, now that just found the triangle, or the triangle's height, right? But now I need to find the area of everything. So the area of this is going to equal, the area of one triangle is 1/2 of the base of the triangle, which is 1, times the height of the triangle, which is root 3. But how many of those little triangles do I get in the whole entire hexagon? 12 of them, so times 12. So if I multiply across the top, this gives me 12 root 3 over 2 on bottom, which cancels out to be 6 root 2. So this, right here, is my, 6 root 3, I'm sorry, thank you. 6 square root of 3. This right here is my base value, right? That's my whole base. Oops, and I shouldn't put a box around it because that's not my final answer. But I'm going to take that base up to this formula that I started, and it's 1/3 times the base, which I just found is 6 root 3, times the height, which is 5. Very good. So multiply across the top, you get 30 root 3 over 3 is 10 root 3. And that is the volume of your pyramid here. All right. One thing I want to emphasize on this. This computation here, was that difficult? The actual volume computation? No. What is the hardest part of this problem? Finding the base, but we've been doing that for a long time now, right? So that technically shouldn't have been too difficult of a problem if you know that the formula is 1/3 base times height. Is everyone comfortable with that one? Okay, so I'm about to take it up a notch. So the next problem I'm going to ask you about is to find the volume of an octahedron. First things first, is an octahedron the same thing as an octagon? No. What is an octahedron? What does it look like to you guys? It's two, not prisms, but square-based pyramids on top of each other. You get 4 equilateral triangles around the top forming a pyramid and 4 equilateral triangles around the bottom. The octahedron, hedron telling you that it's a polyhedron, not a polygon, so it's 3-dimensional. The octa just tells you 8. That means 8 faces, not 8 sides, right? Okay? So if I'm drawing this figure, it should look something like this. Square-based, pyramid on top, and then that same square-based pyramid on the bottom. Everyone see that? All right. Now, when we were doing surface area of the octahedron, it wasn't too bad because all I had to do was find one triangular face area, right? And then multiply it by 8. And to find the area of a triangle, we've been doing that for a very long time. So as long as you knew what an octahedron was, that shouldn't have been very difficult for surface area. Finding the volume of this thing is now going to get more difficult. Okay? How do you guys want to start? Like, if I were to give you this problem on the test, how would you start by finding the volume of this thing? What shape would you break it down to? Just one pyramid, right? You would probably focus your efforts on just the top part of this thing, and then the bottom is the same exact pyramid, just the other way, right? So once you know one of those pyramids, can't you just double it? Right. So what we're going to do to work on this thing is we're going to focus solely just on the top part of this pyramid. So I'm going to draw a picture of it that I can mark up. Now I told you that the edge length is 8. So that means that this is 8, and this is also 8. All right. Now to find the volume of this, what formula am I going to be plugging into to find the volume of this thing? 1/3 base times height. It's a pyramid, right? If it tapers to a point, then the volume is 1/3 of the base times the height. All right, now we're off to a good start because what is the area of the base? What shaped base do you have? It's a square, right? So that's easy enough. 8 times 8 is 64. But here's where I run into a problem. Why can I not use 8 for the height? That's the lateral side. That is not the height, right? Remember, the height is if you stand at the top and drop a stone. What path does that stone follow? So what you guys really need to be able to figure out is what is this distance right here. That's what we need to know. How do we find that? What shape do you look for when you're missing one of the heights in a pyramid? You're looking for, remember I told you, if you're missing either the lateral side or if you're missing the slant height or the regular height. If you're missing one of those heights that you need to know, you need to be finding a right triangle so that you can use Pythagorean theorem. That's what your ultimate goal is, right? Now there are a couple of right triangles that you could draw in here, and either of them would work. So let me just kind of point them out. You could either go down the height and then out to the middle of the face, because what's this distance going to be? 4, and then go up the slant height. You're going to have to do some work, though, to find that slant height, right? Does everyone see how you would find that slant height? You would do another Pythagorean theorem on the face here, right? See that? The other option is you can go out to the edge here so that you can make use of that 8, but then you're going to have to find this radius, which is not 4. And either way works. Where do you guys want to go? You want to go to the what? The apothem? So the apothem is the one that goes straight out to the middle of the face, right? Okay? And that one I think is actually, to me, that one looks easier. So she's saying, let's go head out this way on the apothem, and then I'll have to drop this part down to find that face, right? What do I already know on this piece? I know that this piece right here is 4. I know that I'm trying to find this h, so that should be my variable in the end. The part that I'm missing now is this. I need to know the hypotenuse, and I can find that hypotenuse by drawing yet another right triangle, and that's where this one gets tricky, is you have to actually go through a couple of right triangles no matter how you do it, okay? So we're going to look at another right triangle that I'm going to draw in here, which is the one on the face right here. Okay, so let's take a look at that blue triangle. On the blue triangle, I also know that this distance is 4, right? So can't I find this distance right here, x, by using Pythagorean theorem on that right triangle right here? Okay, so what's my Pythagorean theorem set up there then? For that blue triangle, how would I set that up? X squared plus 4 squared equals, yep, 8 is your hypotenuse on that one, so equals 8 squared. So then that's going to be x squared plus 16 equals 64, right? And then that's going to be x squared equals 48. Now, you could do the square root and find x. However, what are you about to do with the red triangle? Aren't you just going to end up doing x squared anyway with the red triangle? Do you guys see that? Like on the red triangle, my setup is going to be h squared plus 4 squared equals, but it's going to equal that blue x squared that I had, right? So do I really need to solve for x if I'm going to end up squaring it anyway? Can you? And then resquare it? Yeah, you absolutely can. I am just saving myself some work here because I am realizing that, hey, I can take that x value and just dump it right in for that x squared anyway, rather than square rooting it and then squaring it again. Right? Is everyone following me right now? Okay. So what this leaves me with is I'm going to be putting in 48 for that x squared. And then I'm going to have h squared plus 16 equals. So I've now moved on to the red right triangle using the x squared that I had found for my hypotenuse. So this is now x squared equals 48 minus 16 is 32. And now I'll go ahead and square root that because I actually do need the height alone, right? So what perfect square, when you square root 32, what perfect square goes into 32? 16, and when you take 16 out of a root, it is 4. So we're going to have 4 root 2 left over once I take 16 out of 32. Good. All right. So now that is my height right there, right? So I'm now plugging that in as 4 root 2 in that part of the equation. So now to find the volume of this pyramid, all that I have to do is multiply all that across. So if I do 64 times 4, what do I get? 256. Root 2 all over 3. Am I done with the overall problem? Have I found the volume of the octahedron? No, but I am very, very close, right? So at this point, all that I need to know is that the volume of this thing is going to be 2 times the volumes that I just found, right? Because I found the area of just one of my 2 pyramids. So then this is going to end up being 512 square root of 3 all over, or I'm sorry, where did I switch that to square root of 3? I didn't mean to. Shouldn't be, right? What should that be? Square root of 2. Yep, I just switched it when I moved up here. Square root of 2 all over 3. That is my final volume for this thing. Questions on that one? So again, there's a lot going on. Let's just talk through that one more time because it's your most difficult problem, right? So for this one, we had to recognize that I wanted to look at one pyramid at a time. Finding the base was easy, but then to find the height, we had to find a right triangle, and then we had to find actually another right triangle in order to complete the original, right? 2 Pythagorean theorems later, I got my height, plugged it in, solved, and then doubled it. This stuff right here being the most difficult part of the problem. Yeah? All right, so I have 2 more problems left. What's the only shape I haven't shown you yet? Cone, right? So cones are actually much easier than the pyramids. We're through the hard stuff at this point. We want to find the volume of a cone whose height is 10.2 and whose radius is 6.7. So I'm going to draw a quick sketch of this thing. So my radius, I said, was 6.7. The height, and they gave us like just the straight up height, which is nice. The straight up height is 10.2. If I gave you just the slant height, you would have to do Pythagorean theorem to find this height, right? Because we do need the perpendicular height for volume. So just kind of keep an eye out for that in your homework. In this case, though, I know that the volume of a cone, it tapers to a point. So I'm using 1/3 of the base times the height. My base shape is a circle. So what's the area of a circle? Pi r squared. So pi times my radius, which is 6.7, square it, and then that times the height of the whole entire thing is going to be times 10.2. And this is something that, since there's a lot of decimals, I would just tell you to punch that out on your calculator. So why don't you guys do that for me really fast? Type in 1/3 times pi, just use your pi button on your calculator, times 6.7 squared times 10.2. Tell me what you get to the nearest tenth. Yeah?
479.5.
Okay, 479.5. So just make sure that you're typing that all in correctly, okay? And then you're done with that. So again, like I said, the only thing I could do to make this problem more difficult would be to give you the slant height instead of the regular height and make you do Pythagorean theorem to find this part, right? All right. The next problem is one of your working backwards problems. This time I gave you the volume and I want you to find the diameter. Are you going to find the diameter first or something else? Radius is going to be easier to find, and then double your radius again, right? So when I'm looking at this, I know it's a cone. I really don't need to draw a picture of this. If you need to, you can, but I'm just going to go straight into it. So it's going to be the volume equals, which formula am I using? 1/3 base times height, since a cone does taper to a point. What is my volume? 22. And then, yeah, on the other side, you're going to do 1/3 times your base is going to be pi r squared times your height. What's your height? 4. So to solve this, the first thing I want to get rid of is that 1/3. So I'm going to multiply both sides by 3 simply so that I can cancel out the 1/3.
You do that later in the equation, or just do that?
You can do it later. Yep, that's fine. If you want to divide by 4 first or whatever, that's okay. So then I'm going to get 66 equals 4 pi r squared. I'm going to divide by 4 pi with my parentheses around that, right? On this side so that my calculator does it correctly. Okay, so what are you guys getting for that part? When you divide 66 by 4 pi in parentheses, what do you get? What was that? Okay, so 5.2521, and then all we have to do is square root it to the nearest tenth. What do you get? 2.3. Ultimately, I asked for your diameter. What's it going to be? Double it is 4.6. Very good. And you're done. All right, here's your homework. You have volume of prisms and cylinders is section 2.4. Pyramids and cones is section 2.5. Well, if there's not a snow day tomorrow, I would get it done tonight in case there's not a snow day. It's a good chance, you guys, that will happen. So just knowing our school district. So don't count on it being a snow day. Get it done, and then that way if you do have a snow day, guess what you won't have? Math homework. You can enjoy your snow day. Get it done tonight. We'll go over it the next time I see you.